Hey everyone, welcome to the Weather Patterns Unit launch video. My name is Casey and I teach 5th and 6th grade science in Nashville. So you might be wondering what's in this unit. The big unit question students will focus on is why do some rainstorms have more rain than others? To answer this question, students will take on the role of forensic meteorologists. They will investigate how local weather patterns and severe rainstorms impact a fictional town called Galetown, which serves as the anchor phenomenon for the unit. They investigate how water vapor, temperature, energy transfer, and wind influence local weather patterns and how these factors can lead to severe rainstorms. So why does this unit matter, which is something that you might get from your students? Well, severe rainstorms have a great impact on communities and livelihoods by causing flooding and other damage. And so understanding how rainstorms take place allows students to make connections to weather patterns in their own communities. Before we begin, pause here and take a moment to complete your pre-work and continue the video once you're all set. Welcome back everyone. So we'll start by going over each chapter in detail so you'll know what to expect. So in chapter 1, students focus on the question, what causes the rainfall in Galetown? Students watch a video that presents the mystery of Galetown and describes the damage that storms are causing and introduces students to 3 claims that residents have about what is causing the severe storms. Next, students investigate evaporation by exploring the relationship between the amount of surface water and rainfall in the sim. In the following lesson, students complete a hands-on investigation about condensation and read an article about cloud. By the end of chapter 1, students discover that the creation of a lake near Galetown has contributed to the severity of the storms. Students should be able to explain that rain can happen when an air parcel cools and loses energy, which brings us to progress build 1. The loss of energy causes water vapor in the air parcel or air mass to condense and fall as rain. The chapter 1 focus task asks students to express their understanding of progress build 1 by creating a model and then explaining their model with written response questions. Pause the video here and complete the chapter 1 focus task and press play when you're ready to see the rubric and exemplar response. So here is the chapter 1 focus task rubric. And here is the chapter 1 focus task exemplar. Pause the video here to cross-check your response with the exemplar and press play when you're ready to move on to chapter 2. All right, so let's move on to chapter 2. In chapter 2, students explore why the amount of rain in Galetown is different from storm to storm. They begin discovering the temperature gradient in the troposphere and see an in-class demonstration that shows how an air parcel rises when it is warmer than the air that surrounds it. Students continue their investigations by reading about a disaster in California caused by a severe rainstorm. Finally, they investigate further by creating severe storms in the sim that explain the relationship between warm air temperatures and the amount of rain. By the end of chapter 2, students discover that warmer weather has also caused Galetown to have more severe rainstorms. This brings us to progress build 2, where students should be able to explain that a warmer air parcel has more energy, so it can rise higher into the troposphere and lose more energy, which can result in a greater amount of rain. The chapter 2 focus task asks students to express their understanding of progress build 2 by creating a model and explaining their model. Pause the video here and try chapter 2 focus task. Press play when you're ready to see the rubric and exemplar. So here is the chapter 2 focus task rubric. And here is the exemplar response. Pause the video here to cross-check your response with the exemplar and press play when you're ready for chapter 3. Okay, moving on to chapter 3. In Chapter 3, students investigate why the most recent storm in Galetown had the most severe rainfall. Students begin to consider the role of wind in the formation of rainstorms by watching a video that explains how wind can move air parcels higher up into the troposphere. They also investigate air pressure using plastic syringes. They further explore wind and air pressure in the sim by looking at data from real storms from all over the world and reading about weather prediction. Students are able to identify factors that lead to severe storms, including wind. By the end of Chapter 3, students discover that wind caused Galetown to have more severe rainstorms, which leads them to Progress Bill 3, where students should be able to explain that wind can push an air parcel higher into the troposphere, causing the air parcel to lose even more energy, which can result in a greater amount of rain. The Chapter 3 focus task asks students to express their understanding of Progress Bill 3 by creating a model and explaining their model with a written response. Pause the video here to complete Progress Bill 3 and press play when you're ready to see the rubric and exemplar. So here is the rubric for the Chapter 3 focus task. And here is the exemplar response for the Chapter 3 focus task. Pause the video here to cross-check your response with the exemplar and then press play when you're ready to move on to Chapter 4. All right, last but not least, Chapter 4, here we go. So in Chapter 4, students apply their understanding of the ways that water vapor, temperature, wind, all of the things that they've been learning about, how they contribute to more severe rainstorms to a new anchor phenomenon. So they focus on the Carson Wilderness Education Center. In Chapter 4, they will investigate 2 different claims, and they will decide whether or not the Carson was damaged during one severe storm or a series of moderate storms. Students are presented with a wide range of evidence, and they need to decide which evidence is a reliable source. Once they do that, they are able to analyze and create a May data table that tracks the factors throughout the month of May that could have contributed to severe storms. Students will present their ideas to the whole class in a science seminar before writing their final argument in the Chapter 4 focus task. So here is the Chapter 4 focus task, which is in a written argument format. Pause here to complete your Chapter 4 focus task and press play when you're ready to see the rubric and exemplar response. So here is the rubric for the Chapter 4 focus task. And here is the exemplar. Students could have chose from Claim 1 or Claim 2, so there are 2 responses depending on which claim students chose. Press pause here to go ahead and cross-check your response with the exemplar response, and then press play when you're ready to look at the end-of-unit assessment. All right, finally, let's take a look at the end-of-unit assessment. Here's an example of a Progress Build 1 question students will see on the end-of-unit assessment. Pause here and try the question, and then click play when you're ready to see the explanation. The correct answer in this question is C. This answer corresponds with the wording of Progress Build 1, which states that rain can happen when an air parcel cools and loses energy. This is also the only answer choice regarding an air parcel losing energy in the question. Here's Progress Build 2 question. Go ahead and pause here and try the question and click play when you're ready for the explanation. All right, the correct answer here in this Progress Build 2 question is A. It aligns with Progress Build 2, when warm air parcels rise and lose energy. And here is an example of Progress Build 3 question. Pause here and try the question, and then click play when you're ready for the explanation. Alright, the correct answer here would be D. It is the only choice that aligns with the Progress Build 3 statement of wind pushing air parcels up higher into the troposphere, causing it to lose even more energy. Finally, here is an example of a constructive response question. Pause here and try this question, and then click play when you're ready for the exemplar. For constructive response questions, students can score at Progress Build 1, 2, or 3, depending on the depth of knowledge in their response. And here is an example of a rubric and the exemplar. All right, that's a wrap for the Weather Patterns Unit launch video. Thank you for taking the time to prepare so you can make magic happen in your classroom. Your final steps are to finish the entire end of unit assessment, complete your unit internalization guide, don't forget to submit your unit Google form on kippc.org, calendar out your unit, prep your anchor wall, check out your kit, and start prepping your lessons. Best of luck!